Hey everyone, welcome to another NLP Insider live show, and thank you so much for joining us today. We are here live every other week for 15 minutes to talk about everything NLP with industry insiders. I'm David Talby, and I'm the CTO of John Snow Labs. And today I'm very excited to welcome Jennifer D'Souza, postdoctoral researcher at TIB, the Leibniz Information Center for Science and Technology. Jennifer holds a PhD from the University of Texas at Dallas, where she has worked on relation mining from natural language text. Currently, Jennifer is collaborating on the Open Research Knowledge Graph project at TIB, and I'm very much looking forward to learning more about her work and the project. Welcome, Jennifer.
Thank you, David. It's indeed a pleasure to be here. So I am Jennifer D'Souza, and I lead the NLP Services Development for the Open Research Knowledge Graph project, which is a next-generation digitalized scholarly knowledge publishing platform. Indeed, in my decade-long work experience in the NLP field, I have had plenty of opportunities to work on the application of a diverse spectrum of machine learning algorithms over NLP problems, some of which include clustering methods, sequence labeling, sentence completion, pattern extraction, natural language inference, and more recently, question answering. My current research focus is on semantifying knowledge from scholarly text by NLP methods as a knowledge graph. So I look forward then, David, in this interview to share some of my recent experience on knowledge graphs more generally, as well as pertaining to the Open Research Knowledge Graph.
Thank you very much for coming and sharing your knowledge. So you have done extensive research, say in a broad range of NLP problems at different universities, and now you're focusing on knowledge graph construction from text. What caused you to focus specifically on this particular field?
Indeed, I could. In the focus of my research, specifically in the past couple of years, has been on developing hybrid approaches for NLP problems. So basically, this is before I moved to knowledge graphs, the kind of experience I brought to the field. So generally, there is a shared understanding in the research community that rule-based methods offer high precision systems, right? Which, in my impression, is a necessity for systems in the medical domain, where incorrect classifications for patients not having a disease would be a very costly decision. So indeed, a strong justification for reliance on rule-based approaches. Nevertheless, statistical kernel-based methods and recently deep learning methods offer potentially high recall systems since they can generalize beyond seen patterns or new incoming unseen instances. So in the systems developed in the early stages of my career, where we examined the extraction of time and space relations, we often resorted to applying voting or thresholding methods to obtain predictions from the best of two worlds, so rule-based and machine learning. So this past experience seems to weigh in on my current work, developing NLP solutions for the Open Research Knowledge Graph project, where the focus is on knowledge graph construction from text. But presently, the application is a bit unique. So currently, we rely on rule-based approaches for data augmentation to expand the graph with data points from scholarly publications in research fields that are underrepresented. This way, we know the resulting graph retains its high data quality standards. On the other hand, we resort to deep learning for information extraction in research fields that have sizable knowledge base of instances to enable the graph to generalize more, provided the algorithm is fed enough data based on which it generalizes with high confidence.
Okay, that's very interesting. I mean, few questions come to mind, but let's start with that. What intrigued you to focus on this particular field?
So I was particularly intrigued by the semantic web device of knowledge graphs for its capacity to store fine-grained structured information. Not only this, but also its capacity to combine multiple data sources by leveraging generalized schemas as templates for relation linking across various sources of information. So it's fascinating to note how knowledge graphs of themselves are currently the cutting edge technology used to make the internet more intelligent in terms of how it enables information to be presented to the reader by breaking it down only to salient aspects. So for instance, almost all Wikipedia articles on the left panel show what is called as an info box, and this is powered by the crowdsourced Wikidata knowledge graph. So these info boxes nicely complement the unstructured article text by only showing the salient properties of the entities the article is about. So this is a huge benefit for the interested reader who can then assimilate a concise overview of the information in a matter of seconds, as opposed to minutes or hours otherwise needed to scour the unstructured text for the salient properties. So knowledge graphs, from my experience, can enable more intelligent assimilation of information, which is much needed in the present age of information explosion, where the problem isn't that information isn't available, but rather the cognitive burden of having to digest volumes of information. So in terms of combining information from various sources, then the Wikidata knowledge graph itself gets seamlessly linked by the semantic technologies to the Library of Congress knowledge graphs. So we have a generalized set of relations. So then the graph gets further enriched. In the present project where I work, the Open Research Knowledge Graph, we have a similar aim, that of developing akin to info boxes over encyclopedic knowledge, such salient properties representation or info boxes over the main contributions of scholarly publications. So this is both fascinating to me and also a very compelling next generation idea to evolve scholarly publishing from the traditional PDF format to the knowledge graph format.
Definitely. So can you give an example of a specific problem you're trying to solve with the Open Research Knowledge Graph project?
Yeah, absolutely. So in the ORKG project, one of the main questions we ask ourselves is, what if the global scientific knowledge base would be more than a document repository? So this basically focuses on the overall purpose and indeed the specific problem as well. They are kind of like intermingled. So the current deficiency in scholarly publishing as articles pose a lack of transparency and a lack of ability to integrate findings among different research groups. So I can elaborate here. Statistics have shown that approximately 2.5 million new papers are published each year, and this problem is only expounded with articles published in preprint servers and so on. So the problem then researchers are faced with is finding the needle in the haystack. So current search engines no longer serve, because a search, for example, on the CRISPR-Cas genome editing method returns millions of articles. The scholar is then faced with the cognitive burden of manually processing these articles. So now coming to the specific problem that we address, with the ORKG, we aim to capture the contributions or salient aspects of scholarly work in a structured, machine interpretable way, and thus push the boundaries of scholarly publishing to adopt the next generation knowledge graph representation. So over the ORKG, over the graph itself, we have implemented several intelligent applications, such as automated computation of comparisons over article contributions, machine computed surveys, leaderboards of empirical research, etc. And this is all possible over, machine actionable scholarly knowledge when you focus on the contribution aspect. So this can be seen similar to the Amazon search engine, where, salient features of products are reviewed and compared. Similarly, with the ORKG, salient features of scholarly work can be automatically reviewed and compared. So the scholar's work of ingesting knowledge is greatly alleviated from hours or days to just a matter of seconds or minutes. Furthermore, ORKG also promotes open science because once we have the knowledge graph representation of contributions, it presents a transparent and integrable representations of core findings across research. So it's kind of like bridging the research world together.
Interesting. So the specific areas of science that you focus on, like computer science, biomedicine, or physics?
Yeah, that's an interesting question because the Open Research Knowledge Graph has a research fields taxonomy, and this is about 400 research fields wide. So it's very broad and it encompasses mostly all the fields of science. There's always new fields emerging, but as far as we know, we try to capture mostly all the fields of science. So ranging from arts and humanities to engineering to material science and so on and so forth.
Interesting. Because I mean, we've done a bit of work on analyzing papers specific for clinical trial results, right? And then what you care about, you want to know, was this theoretical study or in the field study? Was it on humans or certain animals? What was the results? Like how many patients? Those types of things. And those kind of there's a certain kind of paper that describes that, and you can try to extract the information, but it's super domain specific, right? So if you have something you say in engineering or sociology, it will not apply.
Yeah. You're absolutely right. In fact, we recently created a survey, but a machine actionable survey. So whenever I'm talking about it, I'm not talking about the standard publishing format, but the knowledge graph publishing format of information. And so we tracked down articles that reported the reproductive number estimate of the COVID-19 disease. So that's basically a statistical parameter that determines how fast the disease spreads through a population. And so we kind of identified these salient properties as the estimate, the method that was used to compute the estimate, the location where it was conducted, and the dates of the study, because it's only valid for a certain time period, and created this comparison, nice comparison over the knowledge graph. So I think that kind of helps researchers coming into the field to gain a quick overview of the problem and of this particular statistical parameter without having to scour through the article and note where it was done, or so it kind of
which you really cannot do, right? Because even if it's just COVID, you probably have tens of thousands of papers per month, right?
Indeed. Yes, absolutely. That's right. Yeah.
And this is a super kind of narrow niche of science overall.
Indeed, yes. And so we have to capture narrow niches of science, or as we are experiencing, some problems are more generic. So leaderboards are more generic across artificial intelligence. So that focuses on the task, data set, metric, and score of the model. So we can define generic like subgraph patterns, so that new researchers coming in to enter their model performance in the ORKG can reuse these subgraph patterns. So that's how the graph grows in some domains, but in other domains, as you mentioned, they're very niche problems. And so we could have templates that might be used by maybe 100 researchers only. Nevertheless, it's still good information to have in the graph.
Yeah, definitely. Yeah. So what do you see as the main challenge when it comes to building knowledge graphs from text?
So in general, I would say it's about obtaining, and this again refers back to the discussion we just had, obtaining standardized schemas or ontologies of generic patterns of information that serve specific knowledge capture objectives from large volumes of unstructured text. So, researchers often take one of two approaches, like a top-down approach, where the knowledge capture objective can be defined ahead of seeing the actual data instances. But this takes a large community of data modelers coming together and defining in an iterative way the concept classes of knowledge that must be captured, and then organizing those classes in a knowledge inheritance hierarchy. But there is another approach, which is the bottom-up approach. So here the ontology is discovered from a large-scale collection of data instances. So the data instances are captured first, and then the concept classes are defined with a hierarchy. So at the ORKG, we are indeed taking this bottom-up approach. And the two motivations behind this is, as I just mentioned, the ORKG is spread over 400 or so research fields. And even further, within each field, there are thousands of research problems addressed. Yeah. So for us, adopting a top-down approach is completely impractical. Like, we would never begin. Mm-hmm. So, yes. In the early stages of graph curation, we want to encourage as much the domain expert using the platform to add salient features of their research by choice. So even though it's a challenge, going down the line to discover the automatic ontology, we are indeed relying on the wisdom of the crowd approach.
Interesting. And I think scientific publications are interesting because kind of by definition, when you're writing a paper, you're supposed to be doing something new, right? Including, redefining the field, right? So, some papers you say you can in AI you can have leaderboards, and someone can say, yes, I improved this benchmark by 1%. But then you also have papers that come and say, oh, the whole leaderboards concept is wrong. We should be working on this other theoretical framework, right?
Right, indeed. So, I think in general, like a top-down approach would completely be impractical for us because, as you mentioned, like somebody else can come up with a new theoretical framework for leaderboards, and then that part of the ontology is just destroyed. So, yes. I think, I think
that's what you want in science, right? This kind of evolution.
That's right. Yeah.
So, what problem do you hope to solve with knowledge graphs in the next couple of years?
Okay, so a common sentiment, again, we all share within the ORKG team. We are very united in our purpose here is evolving scholarly communication from a method that seems stuck in the last century. So concretely, we aim then to help lift scholarly publishing from the document-based format to the knowledge graph-based format. So this is to say that we hope to standardize the publishing of scholarly findings as a knowledge graph instead. Personally, since I lead the NLP services development of the ORKG, I hope to help to put in place the needed machine intelligence that could support researchers in adding their contributions to the ORKG. So we are actively working on this, on implementing contribution template population or template recommendation services, and also contribution-centric NER solutions. So in general, personally, I am geared to solving the NLP objectives of seamlessly generating the ORKG. And with the ORKG itself, we wish to solve the problems in the current methods of scholarly communication.
Very interesting. I'm just thinking, I'm involved in publishing several papers per year. It would be interesting to see how those templates look like and how can it join the movement, basically.
We would be very happy to have you on board, in fact.
Sure, that definitely seems like a worthwhile effort. So, Jennifer, thank you very much for joining us today. It was great talking to you and learning from you about constructing knowledge graphs. So for a deeper technical talk on this topic, please join us at the NLP Summit 2022 on between October 4th and the 6th, in which Jennifer will be sharing an exciting talk on the state of the art on knowledge graph construction from text. So Jennifer, I'm very much looking forward to that talk.
Thank you for having me, David. It was a pleasure to be here and exchange ideas, indeed.
Yeah, sure. And I look forward to hearing from you more at the NLP Summit. So thank you, everyone. And until next time.